Hi and welcome. In this video, we will discuss how to interface MQ sensors with Arduino UNO. MQ sensors are having some series of sensors types like MQ2, MQ3, MQ4, MQ5, 6, 7, 8, 9 and 131, 135, 136. These are all the different kind of MQ sensor series. And this is physically look like this. This is MQ2 and this is MQ3, MQ4, and it will look like same, but it is identifying different gases. Either it may be a flammable gas or toxic gas. So either it may be a combination of different gases. So it is identifying the air resistance. That's all. If there is ammonia is available around the sensor head, you can able to understand this is a metal cap is there. So around this metal cap itself there will be a air resistance, there will be a change in air resistance. If suppose alcohol is available around this metal head, so the air resistance will get changed. So this sensors particularly identifying the change of resistance. So this is also called as chemiresistors. So MQ2 it is identifying methane, butane, LPG and smokes, and MQ5 especially it is identifying natural gas and also LPG. Look at MQ4, this is also identifying methane and CNG gases. So this is MQ9, carbon monoxide, CO and flammable gases. MQ7 is selectively it is identifying only CO. So 135, MQ135 is it is also called as air quality sensor. So it can able to identify the combination of or individual availability of CO, ammonia, benzene, alcohol and smoke. So there are different types of MQ sensors are available. Each and every sensor is capable of identifying different sets of flammable or toxic gases. So according to our application, we have to meticulously select the sensors. If it is related to with LPG, you can go for MQ2 or MQ5. If it is related with alcohol, you can choose MQ135. If it is related with CO, you can select MQ7 or MQ135. So these are all the different MQ sensors. So now we are going to interface MQ135 sensor with Arduino UNO. So it is a air quality sensor. We can able to identify CO, ammonia, benzene, alcohol and smoke. So this is the MQ135 sensor. It is printed on this metal case MQ135. It is having 4 terminals. One is VCC and ground, and another 2 terminals are dedicated for sensor output. One is analog, one is digital. Usually digital pins are not actually useful because digitals we know that zeros and 1. So if there is any available of CO or benzene, if it is greater than a specific threshold that is given by the user, if it is going beyond the threshold, this sensor will give 1. If it is not reached that threshold, it will give 0. That's all. So if you want to use the digital output pin from the sensor, you have to set the threshold value. On your program itself, you have to set the threshold value. Or otherwise, simply want to measure all the current gas levels. Then while after watching the gas levels itself, I will decide whether I need to alert the systems or I will need to inform to anybody. I can able to take necessary action after watching the sensor values. If you want to perform this task, you have to read the analog pins. So I'm just connecting VCC and ground to the power supply pins of Arduino board, and I'm connecting this analog output pin to my A4 pin, that is analog pin. So it is high sensitive to ammonia and sulfide and benz, and it is stable, and also it is having long life and detection range. So 10 to 300 ppm, and it is for NH3, that is ammonia, and 10 to 1000 ppm benzene, and 10 to 300 ppm for alcohol. So its voltage is 5 volt. It can able to give, actually it can able to give the values from 0 to 1023, that is 10 bit ADC is available within the Arduino UNO. So 2 power 10, that is 1023. It can vary, it can give the digital output like this. If we want to convert into some voltage value, we need to do some calculation. I will show that calculation in coding part. So its maximum dimension is 18 mm diameter and 17 mm high excluding pins, and the pins are having 6 mm pin width. Actually ppm, that represents parts per million. It is a ratio of one gas to another, as you can see in the screen. For example, 1000 ppm of CO, this represents, you can able to count millions of molecules. I mean 10 lakhs of molecules is there. Among the 10 lakhs of gas molecules, 1000 of them are CO, carbon monoxide, and rest of the molecules are some other gases. So this is the calculation, this is the actual meaning of telling the gas availability in ppm. Actually, one thing we should be very clear, our Arduino UNO is only giving the data like voltage waveform. Okay, so it is only giving voltage value. So it will be converted, it is also possible to convert the voltage value into ppm. There is a specific formula is there, some tedious calculation is there. If you are applying the formula in your code, you can able to convert the entire availability of that particular gas, CO or ammonia or so something into ppm. Now in our demo itself, we will see the code, that the code only represents the value in terms of volt, that is 5 volt as maximum, that's all. Minimum 0 volt, maximum 5 volt. Within the range it will get reflected, it will get varied. Okay, so as you can see in the screen, this is the code I have written to interface the sensor with A4 pin. I am just in void setup command itself, I just connecting, I am calling this command pin mode command, and I'm just calling the pin number A4, and I'm just telling the port is nothing but the input port, and then the serial dot begin. This is very essential because we need to get the data from sensors, right? So from the sensors itself, it is already read, analog read command is already executed by the loop command. So now it is available with Arduino UNO. So from the Arduino UNO to this serial monitor, we need to show the results, right? So it need to send the data. Arduino UNO has to send the data to this laptop through the serial cable. So we need to initiate this command, that is serial.begin, and 9600 is nothing but it is bits per second, right? So it is a ratio called BPS. So it is so called baud rate, right? So with the help of this this value, you can able to set the speed as common. A common bit transaction will be happened between this Arduino board and the laptop, right? So this is setup command, and by the way, the loop command is only having 4 different commands, like my data, that is equivalent to analog read A4. So as I am physically sorry, I am physically connected my analog pin to my 4th pin, analog 4th pin. So I am just before I want to upload the code, then I will explain. It will take some time, right? So it is compiling the sketch. Okay, so from the pin number A4, so it is reading the analog data and it is stored in the variable name called my data. The my data is actually in the float format, and then I am just dividing the whole data by 1023.0 because the 1023 is nothing but the maximum value of the uh, uh, ADC pin in my Arduino. Okay, so what I'm doing is I'm just dividing the maximum number of that particular data stream, and then I'm going to convert into 0 to 5. Okay, whenever if you are dividing the maximum value, dividing any parameter with the help of a maximum value, you can able to convert into 0 to 1. Then if it is convert to 0 to 5 by means of multiplying with 5. That's all. This is a simple calculation. Now this my data is again updated to the same variable name my data. So it is also printed here. So within every 0.5 microseconds, I already told it is 0.5 seconds. I mean for every 0.5 seconds itself. So this reading and printing is happening. So let me check that results now. I'm just go to this option called serial monitor, and yeah, my sensor data is actually sensor data is showing like 0.06 something. Okay, it is showing in terms of volt, right? So it is very low. So my sensor is free from any different kind of gases like CO or ammonia or alcohol. I am just taking this deodorant, and it is also having alcohol is a very important ingredient. Like alcohol is somehow nearly 95%. So I am just going to apply this this deodorant in front of this sensor head. Just you can able to see the values are getting increased, right? So it is the concept of MQ sensors, right? So I am just, you can able to see the green LED is also glowing. That represents the availability of some different gases, I mean alcohol, on the top of that sensor head. And by the way, it is getting distracted, that our gas getting diluted, right? So that our value is getting reduced again. Okay, right? And there is one more option is available in this Arduino UNO, I mean Arduino IDE. I am just closing this serial monitor, and I am going to tools and serial plotter. Okay, control shift plus L. If you are applying this shortcut keys, for pressing this shortcut key, you can able to see this screen. Okay, instead of seeing as a values or text values, this option will give a plot like a graph. Okay, so you can able to see there is no more changes in atmospheric gas. The air is now pure. Okay, now again I am applying the same diode right in front of the gas itself. I am just kindly observe the waveform, right? I am just applying the gas now. Yeah, you can able to see the variation in the waveform, right? So it is getting increased and it is getting stabilized for meanwhile for nearly some fraction of second. It is stabilized and now it is falling back and it is settled at the same value called 0.0 something like that. Okay, so this is the actual the concept behind the MQ sensor. And now again I am just applying the alcohol again. Yeah, now you can able to see a one more peak waveform. Yeah, it is getting increased. Okay, since it is available in atmospheric air, okay, after some kind of time period, the air will get diluted, right? So that means the alcohol in the air will get diluted and it is passing to some other places, right? So the now MQ sensor, around the MQ sensor, metal head itself, the path is, the toxic gas availability is detected as 0.0 something like that. Okay. So this graph that it represents, these are all the time periods whenever the atmospheric air is found with some alcohol. Okay, this is the first period and this is the second period. Okay, so these are all the some disturbance that was happening. Okay, when if I actually mistakenly touched the head, so it is getting disturbed and it is taking time to settle down. That's all. Okay, so this is the concept of MQ sensors, and by the way, we can able to interface the sensor at the required place, and we can able to monitor whether the CO or ammonia or benzene gases are getting leaked or not. Thank you.